It's been a 10-year journey, but Rosetta is finally closing in on comet 67P Churyumov-Gerasimenko. On August the 6th, after the last of a sequence of thruster burns and orbital rendezvous manoeuvres, Rosetta will be 100 kilometers away from the comet. The spacecraft's relative velocity to the comet will be less than 1 meter per second. This walking pace will allow the onboard instruments to study the comet's nucleus, coma, and tails. There are 3 types of comet tails: a gas tail, a dust tail, and an ion tail. Sunlight and the solar wind interact with a comet, and part of the resulting outflow of gases becomes a plasma. The onboard gas and plasma ion and electron sensors will examine this process.
These ions not only form the tail of the comet, but also cause a bow shock to form, because the solar wind is supersonic and it's flowing into the comet, and it's just these pickup ions that are picked up from the comet surface that then load down the solar wind, slow it down, and form a shock wave.
Comet activity was first detected in May. In early June, Rosetta's MIRO instrument made the first observations of water vapour streaming away from the comet, equivalent to 2 small glasses of water every second. By the end of July, Rosetta will be within 1,000 kilometers of the comet, close enough for its Rosina instrument to measure some of the gases from the comet.
The Rosina instrument is designed to analyze the material which comes off the comet when it gets warm, the gases from the ice in the comet, which is mainly water, CO, CO2, but also many organics. And it will do a chemical analysis by mass spectrometry.
Looking at the organic molecules tells us about the history of the comet and the role they could have played for the emergence of life on Earth. Rosetta communicates with the Earth by transmitting radio signals at a certain frequency. These are received by the European Space Agency's S-Track network and NASA's Deep Space Network. The radio signals can also be used for scientific investigations to determine the comet's gravity field and its mass, in effect weighing the nucleus by examining the tiny variations in gravitational forces experienced by the spacecraft when it's close to the comet.
The nucleus is pulling the spacecraft out of its planned orbit, and that can be seen as a shift in frequency of the transmitted radio signal from the spacecraft. And the extent of this frequency shift is a measure of the mass of the comet nucleus, so we are able to weigh the nucleus here.
This is how the mass of asteroid Lutetia was determined in 2010 during a flyby by Rosetta. Now measurements are underway to do the same with the comet. And upon arrival in August, Rosetta will embark on a new series of complex manoeuvres to bring it closer still, so it will be doing what no spacecraft has done before: orbiting a comet.